Good morning. My name is Milan Savasyanov. I am a third year student of the Big Data Analysis program at Asnite University, Group PDA 2305. This is my industrial practice video presentation. I completed my entrepreneurship at Shai Ltd. The practice period from March 9th to May 2nd, 2026, 8 weeks in total. My workplace advisor was Magjan Ikram, and my university supervisor is Adler Doman. In this presentation, I will walk you through the company I worked at, the technical work I completed week by week, the challenges I encountered, and what took away professionally from this experience. Let's start with agenda. Here is the structure of my presentation. It follows the repo structure exactly. I will start with an introduction to the platform I worked with, then describe my workplace in detail. The main body covers an technical section, overview of tasks, platform setup, agent configuration, multi-agent architecture, custom plugin development, internal presentation, and team training. And finally, platform integration into workflows. After the technical content, I will reflect on the challenges I faced, give my conclusion, and list the references I used through the practice. Now, let's start. OpenClaw is self-hosted open source AI agent gateway. It connects messenger channels Telegram, WhatsApp, and so on to AI agents powered by large language models. It handles the full life cycle, receiving messages, routing to the correct agent, assembling system prompts, calling the LLM IP, executing tool calls, and delivers the response back. The platform was created in December 2025 by Peter Sternberg. As the weekend script, you can see the star history chart on the left. By early February 26, it suppressed 180 180,000 GitHub stars. The fastest growing open source project on record, faster than React, Next.js, or Vue. That growth made OpenClaw strategically relevant to Shai Ltd, and my assignment was to research it and the level of its internal architecture and source code. Let's talk about my workplace description. Shai Ltd is a Kazakhstan-based enterprise AI platform company developing AI infrastructure and intelligent agent solutions for clients in banking, government, education, manufacturing, and real estate. The company is a member of the AI Council under the President of Kazakhstan, a participant in the NVIDIA Inception program, and raised a $5 million investment round in September 2025. I was placed in the research and development department as an innovative and AI engineer. My workplace advisor was Magjan Ikram, co-founder and chief R&D officer with over 9 years of experience and master degree in applied mathematics and computer science from Moscow State University. The main subject of my practice was the OpenClaw platform. Overview of task. The core objective was to understand OpenClaw platform, the inside, analyzing its internal architecture, component relationship, and how requests are processed end to end. The deeper goal was laying the technical foundation for an agentic OS, an operating system layer where AI agents act as autonomous executors of tasks, coordinating tools, memory, and external services without constant human intervention. On the slide, you can see the architecture diagrams I produced during the first 2 weeks. On the left side is the hub and spoke architecture. The gateway control plane sits at the center, messaging channels connect from the top, and below sits the agent runtime and memory search, tool executor, and prompt builder. On the right is plugin system for plugin types, channel, tool plugin memory provider. It's covered via package.json and integrated through the plugin loader. The 8 weeks were structured sequentially, weeks 1 and 2 for architectural study, weeks 3 and 4 for step and agent configuration, week 5 and 6 for plugin development and multi-agent coordination, week 7 and 8 for team training and workflow integration. Platform step and initial configuration. The first practical phase was installing and configuration OpenClaw. On the left, you can see the 3 installation commands and the OpenClaw JSON configuration with the Minimax and 2.7 as the LLM provider. On the right is Docker Compose.yml I wrote to contain the deployment exposing port 8789, mounting a persistence workplace volume and injecting AP keys via environment variables. This made the step reproducible on any machine with Docker. The configuration operates at 3 layers: environment variables, override OpenClaw JSON, which overrides built-in defaults. During this phase, I encountered critical issues when I first connected Groundbot. Started with no errors, but receiving zero messages, no responses, no log entry, complete silence. After debugging, I found the root cause and resolved it. A plugin, including built-in channel plugin like Telegram, must be explicitly listing plugin laws of omitted the gateway, silently ignored the channel with no warnings. Once I added the list, everything worked correctly. This taught me this silent failures and more dangerous than loud errors. From that point, configuration audit became my first debugging step. Agent configuration and channel setup. The second phase was configuring 9 specialized agents, front-end, backend, DevOps, and so on, to understand the system prompt architecture. On the right, you can see the real workspace directory listing from the practice. Each agent has its own isolated workspace with agent MD, core behavior and identity, soul MD, personality and tone, tools MD, tool usage guidelines, bootstrap, executes once at startup. Headbit runs periodically for background tasks. And the skills directory with skills MD, playbooks. I developed 3 custom skills: Corda, SuperDev, and CloudDocs. On the bottom right is the system prompt architecture. At some time, all workspace files, memory search results, and session history are assembled into the final prompt sent to the model. Understanding this pipeline was one of the most valuable parts of the practice. Multi-agent architecture and coordination. A significant part of weeks 4 and 6 was dedicated to multi-agent coordination. The foundation is session-based routing. Every message gets a session ID based on source. For example, DM Telegram username for direct Telegram message. The gateway maps this ID to the corresponding agent or space. So one bot token can route different messaging types to complete different agents. I started 3 coordination patterns. First, independent parallel agents with no shared state, which was my primary step. Second, agent to agent via session tools, shown on the right. 4 tools enable this session list to check active session sent to delegate tasks silently, session history to read another agent context, and session span to create a new agent entirely. Third, shared memory index, where agents share the same memory across conversation. The security model is important. Session type determines the tools in box. Main sessions have full access. DM sessions are restricted. Group sessions have the minimum toolset. Custom plugin development. Week 5 was the most technically rigorous part of the practice. My goal was to build a custom tool plugin extending an agent with an external IP call. The plugin package zone is shown at the bottom of the slide. The plugin was discovered by the plugin loader, schema validation, and appeared correctly in tools where both. When triggered it from a conversation, invocation instantly failed. I investigated by reading the compiled source code of internal plugins and found the root cause. Internal plugins use a mechanism called define plugin entry directly wired into the runtime. The public IP pages tool goes through a different code path not fully connected in v2026.4.9. Once I understood this, I resolved the invocation issue and documented the finding for the team. The key lessons for rapidly evolving open source platforms: documentation expresses intent. Reading source code is necessary for production deployment. Internal presentation and team training. Week 7 was dedicated to preparing and delivering an internal technical presentation to the Shy Ltd R&D team. The purpose was genuine knowledge transfer, not status support, but a station that would leave the team able to independently work with the platform. Preparing this presentation required a completely different kind of thinking from the hands-on technical work I had done in the previous weeks. When you learn something through intensive personal experimentation, you understand develop in a particular order following the problems you encounter the path that leads to solutions. Explaining the same system to an audience without the background means I can start it in from first principles. I had to decide what prerequisites knowledge was needed, how to sequentialize technical content, and how to design a live demonstration that would not fail under the pressure of real audience. The topics covered are listed on the right side of the slide. The presentation opened with full hub and spoke architecture view, followed by a live demonstration on the configuration agents responding to real messages in real time. Then I covered the most common configuration mistakes, the plugin loss requirements, the env override hierarchy, and session types and box boundaries. I explained the system prompt, compose, and pipeline, and the purpose of each workplace file. I covered the canvas and A2I capabilities shown in the diagram on the left side of the slide. There's where an agent session HTML to the canvas server, which pushes into the client browser via WebSocket. The user interacts with the render interface, and those interactions return to the agents as canvas action tool calls. Being full agent driven interactive UIs, I also formally presented the plugin implementation with source code evidence as a documented technical findings. The QA session covered deployment option, configuration edge cases, and the platform roadmap. Following the presentation, I produced a written technical references documentation for the team as installation guideline and architecture view and usage scenarios tailored to the team specific tasks. Slide number 11, platform integration into workflows. In the final week, I integrated OpenClaw into the R&D team, actual daily work. The three use cases were implemented: AI news monitoring via current schedules and delivering summaries to Telegram automatically, development assistance with the backend agent accessibilities to Telegram for code review and architectural questions and documentation support through the custom skill and deploy boost. I also documented the production deployment architecture shown on the left SH tunnel, where the gateway runs on a VPC and team members connect through an encrypted tunnel, keeping it off the public internet entirely, and Tailscale server where the gateway is accessible over a private tenant with HTTPs for all team members. The weekend conclude with the final configuration audit across all 9 agents and complement handoff. My reflection. The challenges stands out as the most formative. First, the silent failure as a plugin low emission. The system in crash and simply didn't work with no signal. This permanently changed how the bug configuration auditing is not always the first step. Second, the plugin API gap, finding the answer required reading compiled source code. This taught me to treat open source documentation as express intent, not guaranteeing implementation. Cross refactoring source code is a fundamental skill for product and deployment. Third, the team presentation, having deep personal understanding of a system and being able to explain it clearly to others are completely different skills. Preparing the presentation significantly developed my ability to communicate complex technical content to a professional audience. All planned objectives were completed in full. Every challenge produced deeper understanding than the smooth paths would have. My conclusion. All planned objectives were completed. OpenClaw was deployed on Windows and with Docker. 9 specialized agents were configured. Telegram integration was fully documented. 3 custom skills playbooks were developed. The plugins API finding was documented and shared. Internal presentation and technical references document were delivered. The platform was integrated into the team actual workflows. The relevance to big data analysis is direct. This work covered distributed session management, vector-based memory search, LMP integration, multi-agent routing pipelines, and plugin-based scalable architecture, core components of the specialization. I came in with theoretical knowledge of LLMs and agent systems. I leave the grounded practical understanding of what it means to actually deploy and operate them in a real engineering environment. This is the five primary sources that I used through the practice. The official OpenCloud documentation and GitHub repository were the foundation for all technical work. Cloud Hub is a community marketplace for OpenCloud extensions. Paolo Pizarro's Substack provided architectural context, and the Minimax documentation covers the LLM provider I used. Here is my video presentation. That's all. Thank you.